इस पेपर का नाम क्या है?
बाउंड टेस्टिंग। इसके अंदर
चल पड़ा इंटरनेट।
मुझे एक नंबर ही कहा है कि आपने अगर इक्वेशन बनाई है और आपने ये स्पूरियस रिलेशन फाइंड आउट की, देन हैव टू एस्टिमेट द क्रिटिकल वैल्यू फॉर योर इक्वेशन।
हाँ,
फॉर योर इक्वेशन
अच्छा, क्या मतलब?
कहते हैं जैसे क्रिटिकल वैल्यूज होती हैं हर टेस्ट के लिए, आप भी अपनी क्रिटिकल वैल्यूज फाइंड आउट कर सकते हैं।
चलो इसको डिस्कस करते हैं। This is basically the paper equals a bond testing report to This paper has proposed the test, and let me look at the abstract. This is saying that two set of asymptotic critical values are provided. One, when all the regressors are purely I1, and the other if all are purely I0. These two sets of critical value provide a band covering all possible classifications. Suppose you have a set of 4 variables in which 2 are I1 and remaining are I0. It is some possibility in between. This is also covered. Understand? This is providing 2 bounds. One bound is for all I1 variables, and the other bound is for all I0 variables. And then he is also saying that there is a possibility that some of the variables are I1 and some of the variables are I0. And in this case, the bounds would be in between the lower and upper bound. Every combination will give you a separate bound. Suppose you have 5 total variables out of which 2 are I1, then there will be another bound. If you have the same set of variables and 3 are I1, the bound will become different. But in all the scenarios, the bound will remain in between the lower and upper bound, which are valid for I0 and I1. ठीक? So if you are providing the test, you are applying the test, and it falls below the lower bound, this is equivalent to acceptance of the null of no relationship regardless of the number of stationary variables in the model. If there are 2 stationary variables, 3 stationary variables, n stationary variables, that does not matter. You are below the lower bound, there is no long-run relationship. And if you are above the upper bound, there is long-run relationship regardless of the number of stationary variables in the model. And look at the title of this paper. This paper is not using the word cointegration. What he has written? Analysis of level relationship. Level means long-run relationship. Why he is saying like this? This is because if you have 2 stationary variables, you may have long-run relationship, but that long-run relationship will not be cointegration, because for cointegration, you should have two I1 variable whose linear combination is I0. If you have X which is stationary, Y is stationary, and then linear combination of 2 is stationary, you may have the Lagrange relationship, but this Lagrange relationship cannot be termed as co-integration. So that's why this test will give you the idea of Lagrange relationship, but this is not exactly equivalent to co-integration. It will be co-integration if all the variables in the model are I1, or at least two variables in the model are I1. But suppose you have all I0 variable, this can verify that there is Lagrange relationship, but Lagrange relationship is there, but you cannot verify co-integration, because for co-integration you need the two series to be I1. Okay, so that's it. Now how to apply the test? Basically, let me explain what the difference between Lagrange relationship and co-integration is. Suppose you have xt and yt. This xt is I0 and yt is I0. It is possible to have level relationship. Level means Lagrange. Right? Suppose you have xt which is I1 and you have yt which is also I1. Then these two may have Lagrange relationship. Then Lagrange relationship can exist only if there is co-integration as well. What is meaning of co-integration? X is I1, Y is I1, and then there is weighted sum of the two series which is I0. ठीक? This bound test verifies Lagrange relationship, but it does not verify co-integration, which means it's possible that all of the series are I0 and then there is a Lagrange relationship. And this is also possible that the two series are I1 and then there is co-integration, and that is equivalent to a Lagrange relationship. This verifies only Lagrange relationship, but the test does not verify if there is co-integration. So now let me discuss how to apply this ARDL co-integration. Yes, co-integration by definition is two non-stationary series giving rise to stationary linear combination. Two non-stationary series having a stationary linear combination. Linear combination means weighted sum. Ji? What you are asking, please? I am saying that co-integration means x and y are I1, then there is linear combination which is I0. Okay, so I will apply the ARDL co-integration here. I want to tell you the logic, and basically there are software which will do the things automatically for you, but I want to get little bit awareness of the logic behind this thing. So